Okay, so let's just turn that off. So basically, we said voltage is equal to the energy per charge. Well, the difference in energy per charge between 2 points. We say that 1 volt, it can be defined as a joule per coulomb. And we can calculate the voltage is equal to energy over charge. Really, that should be the change in energy over charge. So I'm going to put a little triangle, which means change in Greek letter delta. And this explains why we have voltmeter in parallel, because we're looking at the difference between 2 points. How does the energy per charge change between 2 points? That's the voltage, otherwise known as the potential difference, because it's the difference in electrical potential energy per charge. And so we can abbreviate that to potential difference, or hang on. So basically, you can call voltage potential difference, or PD for short. Current is the rate of flow of charge, so the amount of charge that flows by per second, which is why we measure it in series, because we just need to see how much charge has flowed by that point per second. So it's going to be, if we like, we could say the change in charge over the change in time. Resistance is it's how difficult it is for current to flow through a particular component, whatever it might be, a wire, a resistor, a light bulb, a thermistor, and so we need to know what voltage would be needed to cause any particular current. If the resistance is high, we're going to need a higher voltage to cause the same current. And so the resistance can be calculated by voltage per current, or voltage over current. So these are the three very, very important equations relating to energy. The only one I didn't talk about was the only word I didn't define was the word charge, symbol Q. So what is charge? Well, basically, we don't really entirely know. We just know that some things have charge, some things don't, and we can have a positive and a negative charge. If it's positive and negative, they get attracted, and if it's identical or like charges, they repel in much the same way as poles of a magnet. But other than that, we don't really know much else about what charge is. We have a unit for it, but that is simply, the more charge something has, the more we'll see this effect. But really, that's about it. And so a lot of people get confused by this concept because they don't know what it is, but rest assured that neither do most physicists. So I won't worry too much about that. Okay, so I'll stop that there.